Hi, so we're going to continue our discussion about adding and subtracting rational expressions with unlike denominators. So you'll notice this first problem we do not have a common denominator, x minus 2 and x plus 2, but our least common denominator, if we decide what they both would go into, would just be them multiplied together, x minus 2 times x plus 2. So when I rewrite my problem, with plenty of room to build a common denominator, I want to multiply x minus 2 by what's missing, and x minus 2 compared to my least common denominator is missing an x plus 2. So I want to multiply the denominator by x plus 2 and the numerator by x plus 2. Likewise, my second fraction with a denominator of x plus 2 is missing the x minus 2, so I need to multiply the numerator and denominator by x minus 2. My next step will be to simplify the numerator, but the denominator I'm just going to write in factored form as the least common denominator, which is x minus 2 times x plus 2. So there is no need to multiply out the denominator. The numerator, though, you must multiply out. So I have x times x is x squared. I'm using the FOIL method here. X times 2 plus 2x. 1 times x plus x, and 1 times 2 plus 2. So because I have an x plus 1 times x plus 2, I must do the first, outer, inner, last. Now here, I need to distribute the x inside. This will be a little easier. X times x is x squared. There's a plus here, so I'm going to pull that down. X squared, and x times 2 is minus 2x. Now what I need to do is combine like terms. I have an x squared and another 1x squared here. That's going to give me 2x squared. I have a 2x plus 1x, that's 3x, and 3x minus 2x is plus 1x, and you could write that as just plus x. And then finally, plus 2. So we have combined all my like terms in the numerator, and in the denominator, I'm going to leave this in factored form. There will never be a good reason to multiply out the denominator. Now I'm supposed to now simplify this expression. To do this, I'm trying to find numbers, I'm trying to factor. Find numbers that multiplied before and add to be 1, and there are not any that do that, so that numerator is prime, which means they have no common factors, and I'm finished with that problem. So moving on to the next problem, I have a denominator of x minus 7 and another of x plus 2. They do not have any common factors. Therefore, my least common denominator is just the two of them multiplied together, very similar to the last one. So I'm going to rewrite my problem, 2 over x minus 7 with plenty of room, minus 3x plus 1 over x plus 2. Now to build my common denominator, I'm going to multiply by what I'm missing. And the x plus 7 is missing an x plus 2. I need to multiply that in both the numerator and the denominator, whereas the x plus 2 is missing an x minus 7. And I'm going to multiply that in the numerator to denominator. Here I distribute the 2 inside. That'll be 2x plus 4 minus. Now I need to multiply 3x plus 1 times x minus 7, but I got to be really careful because of this minus. I'm going to end up subtracting every bit of that. So 3x times x is 3x squared. 3x times negative 7 is minus 21x. 1 times x is plus x. And 1 times negative 7 is minus 7. That's all divided by x minus 7 times x plus 2, the common denominator. Now I'm going to distribute this minus inside as well as add these like terms. So I have 2x plus 4 minus 3x squared because of the negative. Now this minus 21x and plus x is a minus 20x. But when I distribute this negative inside, that's going to make that a plus 20x. And this negative times this negative 7 is plus 7. Over a denominator that I do not need to multiply out, it is good factored. I add like terms. I have a negative 3x squared. I'm going to write that first because that's the highest exponent. 2x plus 20x is 22x. And 4 plus 7 is plus 11 over the common denominator of x minus 7 times x plus 2. You would see if you could factor by finding numbers that multiply to be negative 33 and add to be 22. And my quick thought on that is you're not going to find anything that does that. So this problem is completely simplified. Let's take a look at our next example. 2x plus y over x minus y and x minus 2y over x plus y. Once again, those are not common factors, so our least common denominator is just those two multiplied together. So I'm going to rewrite my problem so I have a little bit of space to work with. And then minus x minus 2y in the numerator. So what this first fraction is missing in the denominator is an x plus y. So I'm going to multiply the numerator by x plus y and the denominator by x plus y. On the other hand, my second fraction is missing in the x minus y. So I'll multiply both the numerator and the denominator by x minus y. This has a lot of work to be done because I need to FOIL both of these numerators. I do 2x times x is 2x squared. 2x times y is plus 2xy. Y times x is plus xy. And y times y is plus y squared. I'm going to do the same thing over here, but watch, I have a minus. So that means I'm going to have to subtract every one of these terms that I come up with. X times x is x squared. X times negative y is negative xy. Negative 2y times x is negative 2xy. And negative 2 times negative y is plus 2y squared. And that's all over our common denominator, and there's no need to multiply that out. X plus y times x minus y. Now my goal is to simplify this numerator by adding like terms and distributing this minus sign inside. So I have 2x squared. 2xy plus 1xy is plus 3xy plus y squared. Now I have like terms right here, that is minus 3xy. And this negative distributes inside and changes every one of these signs. So negative of an x squared is negative x squared. Negative times this negative 3xy is plus 3xy. And negative of a 2y squared is minus 2y squared over my common denominator. Alright. And then like terms, 2x squared I can combine with a negative x squared, which gives me 1x squared. 3xy plus 3xy is 6xy. Y squared minus 2y squared is going to be negative y squared. All divided by x minus y times x plus y. I should be looking to see if I can factor. Are there numbers that multiply to be negative 1 and add to be 6? And there just aren't. So this is completely factored. I don't know if that leaves me enough room or not to do the other problem. So I'm going to erase this work we have just to give ourselves some space. So if you need to pause it to write that down, go ahead and do that. And I'm going to get rid of our problem on the left. And let's take a look at these denominators while I'm erasing. You notice you have an x minus 4 and a 4 minus x. Now they actually do have something in common. If you'll notice, they're just reversed, right? So if I factored out a negative, I actually can get the other one. So like this one, if I factored out a negative, I would make that like a negative 4 plus x, which is the same as negative x minus 4 if I just rearrange these terms. So here's the trick. When you're subtracting and they're in the opposite order, you could factor a negative out, preferably the second one, and that's going to pull, so that turns into this. Look, I'm leaving the first one alone. That's going to be plus x over, now I can write it as negative x minus 4. And this negative can change this to a subtraction. That's really what's happening. So now we have a common denominator, and I can say this is 4 minus x in the numerator over x minus 4 in the denominator. And check it out. Now these are opposite again, and remember, if they're opposite from a previous section, those cancel and leave a negative. We've already talked about how they're related. So that was an unusual problem. Alright, so let's take a look at our next problem. Notice we're subtracting, which means we need a common denominator, but I don't have one. It almost looks like I do, right? Looks like I could multiply this A times an A and this B times a B, but it doesn't work that way. You have to factor completely if possible. This will factor into A plus B times A minus B. Notice we already have an A minus B here, so this is actually our common denominator. All I have to do is multiply this one by an A plus B, and it'll turn it into the second denominator. So when I rewrite my problem, A over A minus B, and then with some space, B over, I'm going to write it in factored form, A plus B times A minus B. Now I'm going to multiply this A minus B times what I need, which is an A plus B. And if I'm multiplying the denominator, I must multiply the numerator. Also, I'm going to have to distribute. So this A times this A is A squared. This A times this B is plus AB. Minus, I'm not doing anything to the second fraction. It's staying as is over my common denominator, which is A plus B times A minus B. And that's it. I don't have any like terms in the numerator. I can't factor that because this is not squared. We are completely finished with that problem. When I look at the next example, I have an x minus y and I have an x minus y squared. Now x minus y squared just really means I have an x minus y times another x minus y. That's what squared means. So when I rewrite my problem with a little bit of space to build my common denominator, this is what I'm looking at. And my least common denominator means, remember, if you have a common factor, it's the most number of times it showed up. So this shows up twice. So I need to multiply this first one by another x minus y to make them match. Which means the next step is I'm going to have to distribute this x inside. So that's x squared minus xy plus y divided by my denominator, x minus y times x minus y. Once again, we would add like terms if we could. But if you'll notice, there's nothing that I can do here. There are no like terms. This is not a polynomial that factors. We're completely finished with that problem. Now here's an interesting problem for you. We've got 3 fractions to deal with, and you're thinking, no we don't. It's 2 fractions and something. Well, this is a fraction because it's over 1. So our common denominator is all of these multiplied together. Y plus 2 times y plus 3 times 1. So our common denominator is y plus 2 times y plus 3. So I'm going to write this with some space so I can multiply by what I'm missing. Okay, so the y plus 2 needs a y plus 3. If I multiply in the denominator, I have to multiply it in the numerator. My y plus 3 is missing a y plus 2 that I multiply in both the numerator and denominator. And this guy down here is missing both. It's missing a y plus 3 times a y plus 2. Alright, so here I distribute. And remember, think about there's parentheses around this. So 2y times y is 2y squared. 2y times 3 is 6y. 1 times y is plus y. And 1 times 3 is plus 3. That is just that numerator. Here I distribute. 3y times y is 3y squared. 3y times 2 is plus 6y. And then we have a lot going on down here, folks. So we have plus y. I'm going to multiply this out first. So y times y is y squared plus y times 2 is 2y plus 3y plus 6. And that is all over our common denominator of y plus 2 times y plus 3. Look at that. And we still have more to do because we have to distribute that inside. So now I have 2y squared plus, now 6y plus y we know is 7y, I'm going to get that over with, plus 3 plus 3y squared. Now I can't add these together because I have to multiply first, so plus 6y, y times y squared is y to the third, y times, now this is 5y, so y times 5y is 5y squared, and then y times 6 is plus 6y. That's all over my common denominator of y plus 2 times y plus 3. We still have a ways to go. Notice I have a y to the third. I'm going to write that first. Y to the third. Let's look at our y squared. So I got a 2y squared and a 3y squared, which is 5y squared. Plus 5y squared is 10y squared. So I've worked with 2y squared and 5y squared and 3y squared. Yeah, it's definitely 10y squared. And I've already handled the y to the third also. So I'm looking at just y. 7y plus 6y is 13y. That's handled. And then 3. Uh-oh. Look, I left off with 6y. So let's back up a little bit. I've got 7y plus 6y is 13y plus 6 more y is 19y. That was handled. And then all I have is a plus 3 over my common denominator of y plus 2 times y plus 3. I would attempt to factor that numerator by grouping, but if you look at that for a minute, you'll see that that won't factor by grouping. So we are finished with this problem. No chance of canceling any common factors. I don't have a lot of room to do this next problem, so I'm going to erase what we have over here on the left. So if you need to pause and write that down, please do. I'm going to go ahead and get rid of it. So we have enough room to work on the next problem. Now if you'll notice, the next problem, we're trying to first find a common denominator because we don't have one. And to do that, I always need to factor my denominators if possible. And x plus 2, there's nothing we can do with that, but x squared plus 5x plus 6 factors. So this factors into x plus 3 times x plus 2. Now if you'll notice, that would be our common denominator because this already has an x plus 2. It's just missing an x plus 3. So when I rewrite my problem with a little bit of space to build a common denominator, there we go. All this is missing is the x plus 3. So I'm going to multiply both the denominator and the numerator by x plus 3. There's a little bit of work to be done here because I'm going to have to FOIL this, very similar to the last one, just maybe not as big. So I've got 5x times x is 5x squared. 5x times 3 is 15x. 1 times x is 1x. And 1 times 3 is plus 3. Plus 2x plus 6. I'm just recopying because remember we didn't have to build a common denominator on the second one. Over our common denominator, which is x plus 2 times x plus 3. Next I want to add like terms. So I have 5x squared. 15x plus 1x. 16x plus 2x is 18x, and then 3 plus 6 is 9. And this is over x plus 2 times x plus 3. Now we want to simplify these answers as much as we possibly can. This is a trinomial with leading coefficient of 5. It's not 1, so I could try the AC method. Are there numbers that multiply to be 45 and add to be 18? So we're checking if there are numbers that multiply to be 45 and at the same time add to be the middle number, 18. So things that multiply to be 45 are 1 and 45. That certainly won't add to be 18. Or, what, 3 and 15. Look at there, 3 and 15 will do it. So I'm going to come over here to the side and work on factoring. 5x squared plus 3x plus 15x plus 9, factor by grouping. X comes out, that leaves 5x plus 3. 3 comes out here, that leaves 5x plus 3. So this factors into 5x plus 3, which is the factor that matched, times what's out front, which is x plus 3, over my common denominator, x plus 2 times x plus 3, and the x plus 3's cancel. So my final answer completely simplified is 5x plus 3 over x plus 2. So notice a lot of work can go into these problems. So I've got 3 more problems I want to do for you. For subtracting fractions, we don't have a common denominator, but you should always factor as much as possible. I'm noticing there's a greatest common factor here of a 3x. That will come out and leave x minus 4. Right here, I'm trying to find numbers that multiply to 16 and add to be negative 8. We're looking at x minus 4 times x minus 4. So our common denominator is going to be a big one. We need a 3, because there's a 3 that shows up here. We need an x, and we need 2 x minus 4s, because that showed up twice over there. Okay, so now I'm going to rewrite my expression in factored form with plenty of space to multiply by what I'm missing. Okay, so if this is my common denominator, okay, I've got a 3x and I've got an x minus 4. So this first fraction is missing an x minus 4. So I'm going to multiply that in both the numerator and denominator. Remember, I need parentheses around what's already there. The second fraction is missing 3x. So I'm going to multiply that in the numerator and denominator. So in this first fraction, I'm going to need to FOIL to simplify that. So x times x is x squared. X times negative 4 is negative 4x. Negative 2 times x is negative 2x. And negative 2 times negative 4 is plus 8. And then over here, I have minus 3 times 3x is 9x over my common denominator, which is 3x times x minus 4. You can write that squared if you want to, or you can write it out twice. I continue to add like terms. I have an x squared. Negative 4x minus 2x is minus 6. Uh-oh. I jumped the gun again. Adding like terms. Wasn't looking at all the like terms for x. Alright, so negative 4x minus 2x is negative 6x minus 9x is going to be negative 15x plus 8 over my common denominator, which is 3x times x minus 4 squared, or x minus 4 times x minus 4, whichever you like better. Now, we would try to factor that numerator to see if there are values that multiply to be 8 and add to be negative 15, and there's just not. So we are completely finished with this problem. Now, I'm confident I'm going to need more space on example T, so go ahead and get example S copied down if you need to. Pause it, and I'm going to erase it, and we're going to do example T. Alright, we're back with space. So I'm adding 3 fractions together this time. None of them have a matching denominator, but I do need to factor this one. Multiplies to be negative 8 and adds to be 2. That's going to be x plus 4 times x minus 2. Notice that's what's over here. So this is my common denominator. So I'm going to write all these fractions down using all the space I have so I can build a common denominator. And notice when I recopy the third fraction, I'm going to use the factored version in the denominator. Now I'm going to multiply by what I'm missing. So to turn an x plus 4 into x plus 4 times x minus 2, of course I'm missing x minus 2. I'm going to multiply that in both the numerator and denominator. I do need parentheses around this because I'm going to have to FOIL. X minus 2, on the other hand, is missing an x plus 4. So once again, I'm going to multiply in the numerator and denominator. I don't necessarily have to put parentheses around this because this is a monomial. I'm just going to distribute inside, but it wouldn't hurt. Now, x plus 4 times x minus 2 already is what it needs to be, so I don't have to multiply anything by the third fraction. So here's where all the work comes in, is expanding. So 3x times x is 3x squared. 3x times negative 2 is negative 6x. 4 times x is plus 4x. 4 times negative 2 is minus 8. Plus 3x times x is 3x squared. 3x times 4 is plus 12x. Plus 4 over our common denominator of x plus 4 times x minus 2. Now I add like terms. I have a 3x squared and another 3x squared. So check it out. If I highlight these for you just to help out a little bit, those are like terms. So I'm going to add those together to get 6x squared. Now what other like terms do we have? I have a negative 6x, a plus 4x, and a plus 12x. So I'm going to combine those together. Negative 6 and a plus 4 is a negative 2. And then that negative 2 plus that 12 is going to be plus 10x. Okay, and then finally the ones that aren't highlighted, the negative 8 and the positive 4 will be minus 4 over x plus 4 times x minus 2. Now our next issue is we need to attempt to factor that numerator because there is a possibility that it has a factor of x plus 4 or x minus 2 or even both. But I see there's a greatest common factor there, so I need to pull that out. That'd be 2, and it will leave 3x squared plus 5x minus 2 over x plus 4 times x minus 2. Now I'm trying to figure out if there's numbers that multiply to be 3 times negative 2, negative 6, and add to be 5, and yeah, there is. So that would be a positive 6 and a negative 1, which means I need to rewrite my expression up here as 2 times 3x squared plus 6x minus 1x minus 2 over, I'm just recopying the denominator. I have to run out of space again. Now we need to do factor by grouping here. So I have the 2 still out front. There is a 3x in common here, and that's going to leave x plus 2. I can factor out a minus 1 here. That leaves x plus 2 over my common denominator of x plus 4 times x minus 2. So all this work and we don't even have any common factors. I'm going to continue. Look, at the top of the page over here, top right, it's going to be 2 times. Now the one that matches is x plus 2 times what's out front, 3x minus 1 over my common denominator of x plus 4 times x minus 2. I had to do that, but there are no common factors. So this is an appropriate answer, but even way back here is an appropriate answer, and even here is an appropriate answer, because when we factored, nothing canceled out. So all of those would be correct answers because nothing canceled. But the thing is, if something did cancel, like if both of these happen to be x plus 2, you would have to go through that trouble to find out. So finally, our last problem, and we have a whole page to do it. We're going to need it. We're adding fractions that do not have a common denominator, which means I need to factor. Well, folks, this is a sum of cubes. So this is going to factor into cube root of x is x. X to the third, cube root of 8 is 2. So that's x plus 2 times, I'm still working on this first factor. You square the first one, x squared. You multiply them together, changing the sign. You square the last one, plus 4. That's just this first denominator. On the other hand, the second denominator, what multiplies to be 4 and adds to be negative 2, does not factor. But look, these share a common factor. The second fraction is only missing the x plus 2. So what I can do is I can multiply the denominator, and then in turn the numerator also has to be multiplied by x plus 2, and now we'll have a common denominator. Alright, so I'm not doing anything to my first fraction because that is the common denominator, which is the same as this. So these are the same. So now I have 3x plus 1, and then remember this is over my common denominator of x plus 2 times x squared minus 2x plus 4. And then here I have to So you can see this clearly. I have to multiply 2x plus 1 times x plus 2. I have to FOIL that. Okay, so 2x times x. Now this is a plus, so that's helpful. 2x squared. We're not going to have to distribute a minus sign. 2x times 2 is plus 4x. 1 times x is plus x. And 1 times 2 is 2. Then we're going to add like terms. So I see a 2x squared and no other 2x squared. So there we go. But now my x, I got a 3x here, a 4x here, and a 1x here. So I add those. 3 plus 4 is 7 plus 1, that's 8x. And then my other like terms are my numbers. I got a 1 and a 2. So I add those together and get plus 3. Over my common denominator of x plus 2 times x squared minus 2x plus 4. Now I'm trying to find numbers that might possibly make this factor. Multiplies to be 6 and adds to be 8. And I can't think of any numbers that do both. Multiply to be 6 and add to be 8. Thank goodness, that means that will not factor anymore and we are completely finished with that problem. As you can tell, a lot of work goes into adding and subtracting fractions that don't have a common denominator. So plan on practicing this a great deal and improve your factoring skills before you do it.